back. Today we're going to be talking about scientific notation as we continue our way through Unit 2. So let's go ahead and get started with a few key ideas. So here we are talking about a few key ideas involving scientific notation. Remember, scientific notation is the way of writing really large and really small numbers. When using scientific notation, we write the numbers as a product of two values. Remember, product being the answer to a multiplication problem. So our scientific notation is always going to look like a multiplication problem. The first value is a number that's going to be greater or equal to 1, but has to be less than 10. The second value is going to be a power of 10. So let's go ahead and take a look at a few examples right now. So here we're going to be looking for values that are written in scientific notation. It says circle all the correct answers. So we have to remember that it's going to be a power of 10, and it's also going to have a number in front that's going to be equal to 1 or greater than 1. So our first number, I see that I've got a 1 in the tens value. It's got first number is going to be equal to or greater than 10. Good. Less than 10. Good. Raised to the power of 10. Yes. So this is a scientific notation. Our second number has got 48 as our first number, and 48 is going to be way more than 10, so that is not going to be in scientific notation. Our next number, 1, that's going to be equal to or greater than 1, so that passes the test, but it's raised to the power of 2, not 10, so this is not scientific notation. Our next number, we've got our first number is 8. 8 is equal to 1 or greater, yes. Raised to the power of 10, yes, so this is scientific notation. My next number, 287, is 287 less than 10? No, so this is not scientific notation. My next number, I've got a 0 in front. 0 is not equal to or greater to 1, so that's not scientific notation. My next number, 3, it's going to be equal to or greater than 1, and raised to a power of 10, check, so this is scientific notation. And my last one, 6, equal to or greater than 1, yes. Raised to a power of 10, yes, so this is also scientific notation. So we've identified all of the numbers that are scientific notation. Notice that their first number is equal to or greater than 1, and they have a product raised to the power of 10. Let's go ahead and look at some more key ideas. So our next key idea asks, how can we convert from between scientific notation and standard form efficiently? In base 10, multiplying by 10 moves the decimal one place to the right. So we're going to be moving one place to the right every time that we have something raised to the power of 10. So let's take a look at our first example. So there we've got 2.8 times 10 to the 5th power. So we're going to be going to the right every time that I see to the 10th power, or a power raised to 10. So here I've got 5. So I'm going to be moving my decimal every time to the right that I have a power of 10, and in this case I have 5 of them. So I'm going to write out my 2.8, and then I'm going to move my decimal to the right for every one of my powers. So that's going to be 5. 1, 2, 3, 4, 5. And what am I going to do with filling in those spaces? I'm going to fill them in with zeros, or fill your basket full of eggs. So what does my standard form look like? 280,000. Notice I put my comma in there. I moved my decimal 5 places to the right because my power is raised to 5, and I've got the correct answer. So let's take a look at the next one there. So I've got 6 times 10 to the 3rd power. So again, I'm going to write out my 6. And then I see I've got it raised to the 3rd power, so I'm going to be moving my decimal. I don't see a decimal here in my problem, but anytime I don't see a decimal, I know it's behind that last number, so I'm going to put my decimal behind the 6, and I'm going to be moving it 3 spaces because that's what it's raised to the power of. 1, 2, 3, and again, fill that with zeros, so my answer there is going to be 6,000. So I've converted scientific notation to standard form. Now I'm going to go back from standard form to scientific notation. Now this may seem a little trickier, but I guarantee you it's just a little counting involved here. So remember, in order to have scientific notation, the first number has to be equal to or greater than 1. So I'm going to be putting a decimal between my 4 and my 9, because if I put it in the right side of the 4, I'd have 49, and that would be too big, so 4 is the perfect number. So I know I'm going to have 4, and then I'm just going to count how many spaces after that decimal to get to my power of 10. So in this case, it's 1, 2, 3, 4, 5, 6, 7. So I have 7 spaces after my 4. Now, I'm also going to make sure that I write down all of the numbers that are not 0. So in this case, I have 4, 9, and 1 is not 0. So I'm going to have 4.91 times 10 to the 7th power. Now let's take a look at the next one there. And again, I'm going to put my decimal point between my 5 and my 0 because anywhere else would make the number in front too big. And then again, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, I'm going to write down all of the numbers that are going to be non-zeros. Now, I have a couple zeros there between my 5 and my 6, but I have to include them because I can't just say 5.6 because it doesn't account for the zeros there. So I'm going to write out everything that I can until I'm out of numbers that are not zero. So I'm going to have 5.006 times 10 to the 10th power because that's what I counted to. Now, this was the way that we could make really, really large numbers, either scientific notation or standard form. So now let's take a look when we have really, really small numbers on what to do. So now taking a look if we have really small numbers, we need to remember that dividing by 10 is the same as multiplying by 1/10, and we remember that from our notes on powers of 10. In scientific notation, this is represented by a negative exponent. So when we have a negative exponent, that means that we're going to be having a very, very small number on our hands. In base 10, dividing by 10 moves the 10th decimal one place to the left. So before we're moving to the right to make a really, really large number, to make a really, really small number, we're going to be going to the left. So let's take a look at our first example there. And in our first example, I've got 9.9 times 10 to the negative third. So again, I'm going to be moving this time to the left. So I'm going to write out my 9.9, and then I'm going to look at my power, and in this case, it's to the negative third. That doesn't mean that my number is negative. I want that to be very clear. My number here is not negative. It's not negative 9.9. Just because I have a negative exponent does not make my number negative. It just makes my number very, very, very small. So in this case, I'm going to be moving to the left 3 spaces. So again, I'm going to count 1, 2, 3, and I'm going to place my decimal point. And what do I fill those baskets with? Some eggs. So then I've got my 0.0099 as my final answer to that problem. Now I'm going to go over to the 4 times 10 to the negative 6. And in this case, again, I don't see a decimal, so I know it's going to be behind that last number. So I'm going to write out my 4. I'm going to put my decimal behind it. And I'm going to be going 6 spaces to the left. I know to the left because I see a negative exponent. Again, I don't have a negative 4 here. I just have a really, really, really small number. So I'm going to be counting to the 6. 1, 2, 3, 4, 5, 6. Place my decimal and fill in the zeros. That gives me with 0.000004. So that was going from scientific notation to standard form. Now we're going to go from standard form to scientific notation. To do this, I'm going to start by placing my number, or placing my decimal point between my 7 and my 5, because again, I want to have one number that's going to be larger or equal to 1. So I have 7 in this case. And again, I'm going to just do some fancy counting. I know that it's a really small number because it's got a decimal point and a whole bunch of zeros in front of that 7. So let's count how many times I moved my decimal. I moved it 1, 2, 3. So since I moved it 3 times, I know again I'm going to have to write out all of the numbers. So in this case, 7 and 5 that aren't zeros. I'm going to have to write out everything that's not a zero. And since I moved my decimal 3 times, I'm going to have 7.5 times 10 to the negative third. Remember, I want to make sure that I show everyone that this number is very small, and the way that I do that is with a negative exponent. So let's take a look at the next one. So for the next one, again, I'm going to place my decimal point after the 3, because that's the number that will be greater than 1. And again, I'm going to count how many times did I move my decimal. 1, 2, 3, 4, 5, 6, 7, 8. So since I moved my decimal 8 places, I know I'm going to have 3 times 10 to the negative 8. And again, I need to have that negative exponent to indicate that I have a very small number. Now let's move on to some practice of you trying it on your own. So here we have a table for you to practice on your own. So I want you to pause the video now, try all the problems by yourself, look back on the other slides if you need some help, and then press play again to see if you are right. How did you do? Were you able to get all of the answers that I did? Hopefully that you got that correct. If not, you want to go ahead and make sure that your chart looks like mine, and then let's move on to the next one. So here we are in example B, and example B is asking us which of these two numbers is greater and how can we tell? So taking a look at the two numbers, we have a bit of an issue to begin with. And the issue is that they have the same number leading them off. We have a 6 here and a 6 here. So since they're both 6, we're going to have to come up with some other way to do this. Now, we could just move our decimals like we just learned, and then we would get numbers, and that would be easy enough for us to tell. But there's a much faster way. Let's start by moving our numbers and seeing which one is larger, and then we'll talk about the faster way. So since I've got 6 times 4, I'm going to be moving or 6 times 10 to the 4th, I'm going to be moving my decimal 4 times. And when I do that, I end up getting 60,000 because I moved my decimal place 4 times to the right, and I ended up with 60,000. And I knew to move to the right because I had a positive exponent. On the other hand, I've got a negative second there, so I'm going to be moving my decimal place 2 places to the left. And when I do that, I get 0.06. So now this seems comical. I know which one is greater. It's the 60,000. 60,000 is going to be way more than 0.06. So I know that's the correct answer there. However, there's a much faster way to do this. And the way that we can do that's much faster than this is we can look at the exponents. The larger exponent is going to be the greater number. So in this case, I have a positive 4 on one exponent, and I have a negative 2 as my other exponent. So I don't even have to take a look at the numbers. I just know that anything to the 4th power is going to be way more or way larger of a number than to the negative 2nd power. So I didn't have to move my decimal. I could if I wanted to make sure that I got it right, but I could just look at the exponents and notice, yeah, to the 4th power is going to be a lot to the more than to the negative 2nd power, and therefore my number is going to be larger. Let's go ahead and take a look at the next example. So here in example C, they're asking us which one is greater. So we can take a look at our numbers first if we want to do that. But if we do that, it's going to be kind of misconstrued. If I have a 9 here, I know that my 9 is bigger than 1. So you would think off the bat that the 9 is going to be the larger number. However, we're going to be talking about scientific notation here. So the exponent to the raised to the 10th is something that matters. And again, I can move my points if I want to and then easily get the answer. But I'm going to just look at the exponents in this case. And then I look at the exponents in this case, I see that the 8 is much larger than this 1. And since the 8 is much larger than the 1, I know that 1.5 to the 8th power is going to be much larger than 9.2 to the 1st power. And again, I can move my decimals to check it. If I do that, I end up with 92 on one side and 150 million on the other side. And obviously 1 is much larger. And the way that I know that is we again can look at the exponents, and the larger exponent is the greater number in this case. Let's look at one more example. So here we are in example D, and they kind of threw us a curveball. If we take a look, it's like, okay, which one is greater? And I've learned from the last 2 examples, I can just take a look at the exponent. However, in this case, I've got an exponent of 8 on one side and an exponent of 8 on the other side. So since the exponents are the same, how am I going to figure out which one is greater? Now again, I could move my decimal places to the right or the left, whichever it's indicating to me. That will give me the right answer. However, there's a better way to do that. Since I know the exponents are the same, then I'm going to be looking at the base number to give me the correct answer when the exponents are the same. So in this case, I've got a 3 on one hand and I've got an 8 on the other, and I know that 8 is larger than 3. And if I were to move my decimals, I would find it to be the same thing. 820 million, a lot more than 370 million, although they're both large numbers. The 820 million is larger. So I know that is my correct answer in this particular problem because it had a larger base number when the exponents were the same. Now let's move on to some practice problems you try on your own. Here we are at practice number 2. There are 2 problems for you to try there on your own. So I want you to go ahead and pause the video, do them both, and then press play again to see if you are right. How did you do? Were you able to figure out both ones? The top one, the numbers were the same, but the exponents were different. And on the bottom, the had to just take a look at the base numbers. That would not have been good because the 7 is greater than the 2, but the 5th power is greater than the 4th power, so that is how that one is greater. Let's go ahead and take a look at the next one. So here we are at example E, and example E says order these numbers from least to greatest. Well, good news. I could take all of these numbers and I could start moving decimals left and right and lining up really large and really small numbers with all of their decimals and trying to figure out which one is the largest. Or I can use that trick I just learned about looking at the exponents. So that's what I'm going to do here since all of the base numbers are different. So I know that I've got it to the 2nd power, to the negative 7th power, and to the 4th power. And of those numbers, which one is the smallest? The negative 7th power is going to be smaller than the 2 positive values there. So I know negative 7 is going to make the number really, really small, whereas the positive exponents are going to make the number really, really big. So negative 7 is going to be the one that is going to be the least, or raised to the negative 7 is going to be the least. Then I've got 1.6 times 10 to the second and 2.7 times 10 to the fourth. And I'm going to take a look, and I realize that to the second power is going to be smaller than to the fourth power because 2 is smaller than 4. So that is going to be next, which leaves me with just 2.7 times 10 to the fourth as my last choice. If you did not fill in as I did, you want to go ahead and make sure that your paper looks like mine. And let's go ahead and take a look at one more practice problem. So practice number 3 says order these numbers from least to greatest. So I want you to go ahead and try this one on your own. You're going to pause the video now, put them in order from least to greatest, and then press play again to see if you are right. How did you do? Were you able to get all of them in order from least to greatest? A little bit of a curveball here because 2 of the exponents were the same, so you had to take a look at their base numbers, but hopefully you were able to figure it out. If you did not, make sure that your paper looks like mine before we finish up. But this brings us to the end of this video, so if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.